In this video, we'll take up the power law of logarithms homework sheet. So the first question says, use the power law to evaluate without using a calculator. So yeah, just apply the power law, and it really makes evaluating the logarithm much simpler. Just remember here for 1z, cube root is a rational exponent of 1/3. So that's why I wrote 1/3 over here. For number 2, now that you know the change of base formula, you can evaluate these logarithms and find an approximate value. So it's about 1.756, 31.495. So yeah, I use a change of base formula to find out what the approximate values are. For number 3, we're just basically letting n equal 6 because it's asking me what's the displacement after the 6th swing, and then after how many swings will it be less than 1 meter. So if you do the math, it will take 10 swings to be less than a displacement of 1 meter. For number 4a, it's just evaluating using the change of base formula. So nothing special there. For number 5, you're going to write it as a single logarithm. For number 5, single logarithm. So since the bases are both 10, you can express it as a single logarithm, and then they ask you to evaluate. So these ones you don't need a calculator because they work out very nicely. Like 4 squared, you should know is 16. For 6, we did the power law of logarithms, and then just solve for x. Yep, power law of logarithms and solve for m for 6b. For number 7, verify that the average temperature is 12 degrees Celsius in 2008. So I let the year be 2008 and then I solve for t, and I basically get 12 degrees Celsius. So it is true. For 7b, in what year will the average temperature be 15 degrees Celsius? Just let t equal 15 and solve for y. You will need to use the change of base formula for your calculator to change it to a base of 10, unless you have those special calculators. Number 8, after how many years will only 25% of the original amount of the radioactive isotope remain? So let a equal 25 because we're working with 25% left, and then solve for t. This one you don't need a calculator because log base 2 of 1/4 you should know is -2. Now for 8b, it says after 20 years, what's the amount left? If you do the math, it's 96.6%. A lot of it remains because the half-life must be a long time. Yeah, half-life is 400 years. That's why after 20 years, majority of this radioactive isotope is still there. Okay, 9. So why are we not allowed to have a base of 1? So they asked me to do it 2 ways. First, using the converting it to exponential form, and I get 1 to the x equals 5. Well, 1 to the x cannot be equal to 5 because 1 to the power of whatever is 1, right? As long as x is a real number. So 1 to the power of x is not 5. So that is one way of explaining why the base of the logarithm cannot be 1. Another way of explaining it is using the change of base formula. Because log base 1 of 5 is log 5 over log 1, but log 1 is 0. So once again, that's another way of saying or seeing why the base of the logarithm cannot be 1. Okay, so that is the homework sheet for power law of logarithms.